Welcome to Black Hole Basics, where we explore the deepest mysteries of the universe, starting with the most haunting question ever. Look up at the night sky and count the stars, realizing that for every grain of sand, there are thousands. Astronomers estimate there are about nearly 200 billion trillion stars in the observable universe, a number beyond human comprehension. Many of these stars are very similar to our Sun, and many are circled by Earth, like planets with liquid water. If even a tiny fraction of these planets develop life, the universe should be teeming with diverse and advanced civilizations. Yet, when we point our most powerful radio telescopes at the stars, all we hear is the sound of silence. This leads us to the famous moment in 1950 when physicist Enrico Fermi asked his colleagues, "Where is everybody?" This contradiction between the high probability of extraterrestrial life and the lack of evidence is known as the Fermi paradox. It forces us to confront uncomfortable possibilities about our place in the universe and the future of our own civilization. Are we truly alone in this massive void, or are there others out there that we simply cannot see yet? To understand the odds, Dr. Frank Drake developed an equation to estimate the number of active civilizations in our galaxy. It multiplies the rate of star formation by the fraction of stars that have planets and potentially habitable environments. It then factors in how often life develops, becomes intelligent, creates technology, and how long that civilization can actually survive. Depending on the values we choose, the equation suggests there could be anywhere from 0 to millions of civilizations out there. Even with conservative estimates, the numbers suggest we should have detected a signal, a probe, or a structure by now. The universe is billions of years older than our solar system, giving other civilizations plenty of time to develop technology. On the Kardashev scale, a Type 1 civilization can harness all the energy falling on its planet from its star. A Type 2 civilization is capable of harnessing the total energy output of its star, perhaps by building a Dyson sphere. A Type 3 civilization controls the energy of its entire galaxy, appearing to us as a godlike force of nature. Calculations show that a spacefaring civilization could colonize the entire Milky Way galaxy in just a few million years. Since the galaxy is billions of years old, aliens should be here, but they are not. So, where are they? The first solution is the rare Earth hypothesis, suggesting that the conditions for complex life are incredibly specific and unique. While microbial life might be common, complex intelligent life requires a perfect chain of coincidences that rarely happens elsewhere. We have a large moon that stabilizes our axis and climate, a feature that might be incredibly rare for rocky planets. We also have a gas giant like Jupiter to shield us from constant asteroid bombardments that would sterilize the surface. Our solar system is located in a quiet spiral arm, far from the chaotic radiation of the galactic center. It took billions of years for single cells to become complex organisms. This step might be the hardest hurdle of all. Perhaps the universe is filled with dead rocks and slime, but we are the only ones who can look up. If the rare Earth hypothesis is true, we are incredibly lonely, but also incredibly precious to the history of the universe. The second solution is darker. It is called the Great Filter, a barrier that prevents life from reaching interstellar colonization. The Great Filter is a probability threshold that makes the transition from life to advanced civilization almost impossible to achieve. This filter could be behind us. It might be the emergence of life itself, or the leap to complex cells. If the filter is behind us, then we have already survived the hardest part and have a bright future ahead. However, the filter might be ahead of us. Advanced civilizations may tend to destroy themselves once they discover powerful technologies. Nuclear war, genetically engineered superviruses, or artificial intelligence could be the traps that wipe out civilizations before they spread. Climate change and resource exhaustion might cause societies to collapse back into the Stone Age before they can leave their planet. If the Great Filter is ahead, Finding alien ruins on Mars would be the worst news humanity could ever receive. It would mean life is easy to start, but something stops it from lasting. That something would be waiting for us. We must ask ourselves if we are currently approaching the Great Filter, and if we have the wisdom to survive it. The third solution involves the sheer scale of the universe. Space is vast, and time is incredibly deep and long. Even at the speed of light, communication across the galaxy takes tens of thousands of years. Real-time conversation is impossible. Civilizations might be separated by such vast oceans of emptiness that they simply never detect each other's faint radio signals. We might also be missing them in time. Civilizations could rise and fall like waves, never overlapping in existence. Aliens may have visited Earth millions of years ago when only dinosaurs roamed, finding nothing of interest and leaving. Or they might arrive millions of years in the future, long after humanity has ceased to exist on this planet. Our radio bubble has only reached about 100 light years. That is a tiny drop in the galactic ocean. To the rest of the galaxy, we are essentially invisible and silent. We have not been loud enough for long enough. The fourth solution is the zoo hypothesis. This suggests that aliens know we are here, but are deliberately avoiding contact. Just as we observe animals in a nature reserve without interfering, advanced civilizations might be watching us evolve naturally. They may have a prime directive to let primitive societies like ours develop culturally and socially without external contamination. Perhaps they are waiting for us to reach a certain level of maturity or peace before they reveal themselves. A darker variation is the dark forest theory. It suggests the universe is a dangerous place filled with predatory civilizations. In this scenario, every civilization stays silent to survive. Revealing your location invites destruction from more advanced, hostile species. Humanity, by broadcasting our location into space, is like a child shouting in a dark forest full of wolves. If this theory is true, the silence of the universe is not emptiness, but fear. Everyone is hiding to survive. The fifth solution suggests that we are simply too primitive to understand or detect the signals that are already there. We are listening for radio waves, but advanced civilizations might use lasers, neutrinos, or gravitational waves to communicate across stars. Trying to catch their signals with our radio telescopes might be like trying to catch a Wi-Fi signal with a smoke signal. Imagine ants next to a highway. They have no concept of the cars or the humans passing by. We are the ants. The universe might be filled with the galactic internet of data that we simply do not have the hardware to access. Their logic, mathematics, and consciousness might be so different from ours that we wouldn't recognize them as life at all. Some believe the solution is simple. They are already here. This brings us to the topic of UFOs and government secrets. While most sightings are errors or hoaxes, a small percentage of unexplained aerial phenomena keeps the hope or fear alive. They might not be in giant ships. They could be microscopic nanoprobes monitoring our biosphere without us ever noticing them. So, how do we solve this paradox? The future of the search for extraterrestrial intelligence, or SETI, is brighter than ever. New telescopes like James Webb are analyzing the atmospheres of exoplanets, looking for chemical signatures of biological life. We are also looking for technosignatures such as artificial lights, industrial pollution, or heat emissions from massive alien megastructures. Projects like Breakthrough Listen are scanning millions of stars with greater sensitivity than ever before, listening for that elusive hello. Artificial intelligence is now helping us sift through massive amounts of data, looking for patterns that human eyes might miss. Regardless of the answer, the implications of the Fermi paradox are profound and change how we view our own existence. If we are alone, it means we are the universe's only way of experiencing itself. We bear a massive responsibility. We must protect the fragile flame of life on Earth, for if it goes out, the universe returns to silence. If we are not alone, it means we are part of a vast cosmic community, and we have much to learn. The discovery of alien life would unite humanity like nothing else, making our wars and borders seem incredibly petty and small. The Fermi paradox inspires us to keep exploring, to keep asking questions, and to never stop looking up at the stars. Our probes are leaving the solar system, carrying messages of peace and music, hoping that one day, someone will find them. We are becoming a space-faring civilization ourselves. Perhaps one day, we will be the aliens that another world discovers. The next time you look at the night sky, remember that the silence is not empty. It is full of possibility. Whether we find neighbors or discover we are alone, the journey of exploration gives meaning to our existence as humans. From the rare earth to the great filter, from the dark forest to the zoo, the answers remain hidden in darkness. But science is the tool we use to light up the dark. Every day, we get a little closer to knowing. The universe is vast, cold, and silent, but it is also beautiful, and we are the eyes of the universe. Let us take a moment to reflect on the sheer scale of time that has passed before we even existed. The scale of stars themselves is mind-boggling. Our sun is a grain of sand compared to the giants out there. In these stellar nurseries, new solar systems are being born right now, perhaps creating new homes for future life forms. Comets and asteroids wander the void, potentially carrying the building blocks of life from one star system to another. Even in our own backyard, moons like Europa and Enceladus might hide oceans of life beneath their thick, icy shells. Titan offers a completely different chemistry for life, with lakes of methane instead of water. Could life exist there too? We have had false alarms, like the famous wow signal, which remains unexplained to this day, teasing us with possibilities. We have built massive ears to listen to the cosmos, dedicating decades of human effort to answering this single question. Now, we link telescopes across the entire globe, turning Earth itself into one giant eye staring into the deep dark. Perhaps life is abundant in other universes, and we just happen to live in a lonely one within the multiverse. We look for carbon-based life like us, but alien biology might be based on silicon, existing in extreme heat. Could life exist inside stars? Plasma beings formed from magnetic fields and energy might be thriving right before our eyes. The theory of panspermia suggests life spreads like a virus, hitchhiking on rocks to infect sterile planets with biology. Biological life might just be a temporary stage to create machine life, which then dominates the galaxy for eternity. Maybe there are no aliens because we are living in a simulation, and the programmers simply didn't code them in. If we are in a simulation, the Fermi paradox is just a parameter setting chosen by the creator of our world. Science requires patience. We have only been looking for a split second in cosmic time. We must not give up. The answer might be found by someone watching this video right now, a future scientist who will solve the puzzle. We are designing ships that could reach the nearest stars within a human lifetime. The search will soon become physical. Alpha Centauri calls to us. It is the first step into a larger world, waiting for our arrival. Imagine the moment of first contact. It will define a before and an after in the history of our species. Religions, philosophies, and governments would have to adapt overnight to the realization that we are not the special center. But until that day comes, we can find peace in the beauty of the stars and the mystery they hold. Down here on Earth, life goes on, but the question hangs above us, eternal and silent. Where is everybody? This has been a special presentation by Black Hole Basics. We hope it has expanded your mind and your imagination. A huge thank you to our supporters who make these deep dives possible. You are the fuel for our journey. Remember to subscribe for more weekly space documentaries. This is Black Hole Basics, signing off from the edge of space. If you enjoyed this journey through the Fermi paradox, please like this video and subscribe to join our cosmic exploration. Click on the video appearing on your screen now to dive into the mysteries of black holes and time dilation. Click on the video appearing on your screen now to dive into the mysteries of black holes and time dilation.